In software engineering, we are taking chapter number 19, Quality Concepts. McCall's quality factors. Now, McCall, his colleagues Richards, Walters, they proposed categorization of different factors, attributes that affect the software quality. So actually they wanted to define the software quality. So there are certain factors that are affecting, and they focused on three very important aspects of a software. The first one is the operational characteristic, that is the product operation. When a software will be used, what are the characteristics, features, functions? Ability to undergo change, that is product revision. If you change the software, how does this software change easily, or what are the effects? Finally, the adaptability to new environments, that is product transition. So all of these major category, they have underlying different attributes. So this is the triangle, McCall quality factor triangle. In product operation, we have certain factors, revision we have certain factors, and product transition, these are certain factors. So all these factors were defined by McCall. What are these doing? Why are they important? For example, the product operation, let us start with correctness. So correctness is extent to which program satisfies the specification and fulfills the customer's objective. That is, if you have defined or decided certain specification, the degree to which this software is conforming to this specification. Reliability, that is extent to which program can be expected to perform its intended function with required precision. That is, the function which is being defined, it is doing, and it is doing it reliably with required precision. We'll talk about reliability and availability later. We'll give a proper mathematical definition. But for now, reliability, that we can rely on it. Proper function. Efficiency, see, it is going to work on some computing device. That computing device will have certain resources. That is how efficient this program is going to use the system resources, the computing device resources. This is the efficiency. Integrity. Integrity is if someone like he is unauthorized, if he is want to enter access, how do we control his access as far as software and data is concerned? Access. Usability is when a novice or a new person is using the software, how much effort he should put to learn, operate, the input he wants to give, the output he wants to interpret, because input output are also very important. So learning, operating, and the input output interpretation. Usability. Maintainability is if some problem is there, some error is there, how to first locate it and then to fix it. How much effort is required? That is the maintainability. There is a whole part of software engineering, that is maintenance. Then comes the important part, which is flexibility. That is, you want to modify a program which is already operational. How much effort is required to modify this operational program? Testability is the effort required to test a program, test a software. Portability. Now, there are different hardwares and software platform. Now, you want to transfer or do transition, perform transition from one configuration to another. How much effort is required from one hardware to another, one configuration to another? This is the portability of McCall. And this comes under the product transition. Reusability. Do we have any part or parts of the program that may be directly reused in other application? Reusability. Interoperability. That is, if one system is there is another system. How much effort is required to interface them and to couple them? To means combine them, interconnectivity. So all these things we have seen, but there is one consideration, that the matrix, because we want numbers. So all these different McCall quality factors, they are good to know, they are good, and we can also easily find the quality. But in order to find the mathematics or the numbers, we may not be able to get it directly. But this gives a quality input for us as a software people. ISO 9126 quality factors. This is ISO IEC 9126. So ISO is International Organization for Standardization. So ISO, this standard, this was developed in order to identify what are the key quality factors, attribute, features for a software. So they divided it into major parts, and all these parts are again dependent on certain factors. For example, if you take FERPS, if you take McCall, all these are all about showing the quality, representing the quality and defining the quality of the software. So when it comes to ISO 9126, the major thing is functionality. Now here are the required functions available in the software. That is the degree to which the software satisfies the stated needs. The software is made for America. Is it doing work for, say, China? Don't know. So this is the functionality. Suitability, accuracy, interoperability, compliance, security. If degree is about 100%, 90 is achieved. So now we have a degree here. The degree to which these specifications are satisfied, the work being needed. Then the reliability. The amount of time, the span of time the software is available for use. If a user wants to use the software, is it available? And without any failure? So the underlying factors here are maturity, fault tolerance, and recoverability. Usability. Usability is the software easy to use? That is the degree to which the software is easy to use. If someone comes, he is able to understand the software, learn easily, and then operate on it, to work on it. So these are the usability. Efficiency. The degree to which software makes optimal use of the system resources. That is, the software is going to work on some certain system. The time complexity, the space complexity, the time behavior, and the resource behavior. These are the two factors which are defining efficiency here. Okay. So the system resources have to be used very efficiently. Maintainability. Now, there may be some problem, bug fixing. That is what we call in as a repair of the software. So here comes analyzability, changeability, stability, and testability. Portability, one environment to another. You want to change the software, transform or transfer the software application. So here comes the adaptability, installability, conformance, and replaceability. So all these are the ISO quality factors 9126. But still this gives you a very good idea about quality for everyone. But there has to be some measurement criteria. Until we measure, we will not be able to know the numbers. So though things should not be, subjective. Okay. So ISO 9126 quality factors. Either FERPS, McCall or ISO 9126, all are for quality. Targeted quality factors. So whenever we talk about quality, McCall or any other qualities presenting standard, they are identifying certain thing and they have to define also. So just by knowing that these are McCall factors, learning and mugging up is not important for us. I'll give an example. Let us know what do we do actually. For example, in McCall triangle, we have a usability in product operation. If your boss tells you, okay, need to check the usability. How do you check it? In order to check usability, that okay, tell me that this is the user interface where user is going to interact with the application, software, website or web app. Now you have to review and assess the usability. Usability is a quality factor. So how do you do it? In McCall, the usability consists of understandability, learnability, and operability. When we learned the McCall, I told you. So all these three things you have to assess. So in order to do the assessment, in order to conduct the assessment, you need to address specific measurable attributes of the interface. So measurement is very important. For instance, the first thing comes here for usability is intuitiveness. That is the degree to which the interface follows expected usage patterns so a novice can use it without significant training. If a new person comes, how much effort is needed? So we need to ask certain questions. Intuitiveness is all about this. So the first question can be, is the interface layout conducive to easy understanding? Have you made, or that user interface is made like this? Are interface operation easy to locate and initiate? Have these operations being hidden? It is hard to find them. Does the interface use a recognizable metaphor? A event, a content, an icon, is it recognizable? Or it is something out of the box? Is input specified to economize keystrokes or mouse clicks? That is, for any word, say you need to use keyboard 5 times. Can it be made 2 times? That is, the effort has been reduced. The efficiency is better. Have they made it easy? Does the interface follow the 3 golden rules? Now 3 golden rules for interface, UI or UX, I'll talk about that later. But for time being, you need to understand that usability testing is all about being useful, findable, accessible, usable and desirable. Does aesthetics, the beautifulness, aid in understanding and usage, or does the aesthetics creates a problem? The second thing comes for usability testing of user interface is efficiency. That is the degree to which operation and information can be located or initiated. The operation, function, feature, how are they located? Can it be initiated easily? What is the efficiency? So the question you are going to ask is, does the interface layout and style allow a user to locate operation and information efficiently? Does the layout is consistent? Or is the novice user able to use it without problem, efficiently? Operations are clearly seen, information is very visible. Does the interface layout hiding something? The style is not consistent. Can a sequence of operation be performed with an economy of motion? That is, for a special word, you have to do 10 operations. Maybe it can be, pressed into 2. Are output data or content presented so that it is understood immediately? Have hierarchical operation been organized in a way that minimizes the depth to which a user must navigate to get something done? User is lost or he gets everything. The next thing comes is robustness. The degree to which the software handles bad input data or inappropriate user interaction. Now user is a king. He can do whatever he wants. Sometimes wanted means knowingly, unknowingly. So does this software handle these things? Will the software recognize the error if the data values are at or just outside prescribed input boundaries, boundary values, analysis? More importantly, will the software continue to operate without failure or degradation? Some number is given, 360. It can go up to 360, some angle. What are you putting 361? What is happening? 359.99, what is happening? And even if it happens, is there graceful degradation? Or you get about retired, done. Will the interface recognize common cognitive or manipulative mistakes and explicitly guide the user back on the right track? If something bad happens, is the user guided to go to that position where he can restart? Does the interface provide useful diagnosis and guidance when an error condition is uncovered? For example, some error code. Error will happen. But does it provide, oh, this has happened, this is the error code, now you must follow these? That is, a graceful degradation or a failure tolerance is there. This is called the robustness. Okay. Then comes the richness. The degree to which the interface provides a rich feature set. How much feature it is providing. and a useful feature. Can the interface be customized to do the specific needs of a user? Can the plugins be applied? Is something not available in that application which a user really wants? Does the interface provide a macro capability that enables a user to identify a sequence of common operation with a single action or a command? For example, if you go to GIMP, very popular image processing software. Now, there are multiple operations you have to do, but these operations can easily be clubbed into a batch. And for an image, you just apply this batch. All these operations can be done easily. So is something of this sort is there? If I answer to all these questions, most of the questions, majority of the question is yes, the user interface is highly likely to show a high quality, a good quality, a better quality. I hope you got the idea how user interface can be checked. This is done for all of others. The cost of quality. Everything cost, even the quality cost. So I'll give you a very good sentence. We know that the quality is important, but it costs us time and money. Time, effort, money, resources. Too much time and money to get the level of all software quality to the best possible. Do we really want that? Because achieving a 100% quality, you need to put all the resources, money and time, everything. So there are two things which comes. Quality has a cost. That is, in order to achieve quality, we need to spend effort, time, etc. But there can be a lack of quality. There can be quality which is not there. So what is the cost incurred when a low quality software is delivered? So which cost we need to be worried about? Cost of achieving quality or cost of low quality software? So cost of quality, we can divide it into three main key players. First is prevention, appraisal and failure. That is, we know the maintenance. So giving you an analogy, preventive maintenance and corrective maintenance. In between also something comes. I'll discuss about all these figures, but before that, the cost of quality is prevention, appraisal and failure. What are the prevention costs? That is, we want to prevent something to happen. So cost of management activities, first we have to make a plan and we have to do all the quality control, coordinate them, plan them, manage them and the quality assurance activities. Then the cost of added technical activities, because if you have developed some requirement, you have developed a good design. So all the coding and testing should be done according to this. So there will be added technical activities. All these test planning, because testing is an important factor. There will be cost. And in order to do all this, you need trained people. So in order to train, there will be cost. I hope you got the idea of prevention cost. Then comes the appraisal cost. Now, appraisal cost is you want to see and you want to find if something is bad or good. So this includes activity to gain insight into the product condition the first time through each process. You want to see, you want to appraise, you want to find out, verification, validation. That is, you need to do the technical reviews. For that, a cost will be there. So cost for conducting technical reviews will be there, comes under the appraisal costs. You need to collect the data. You need to collect the metrics. You need to analyze them. You need to find facts and figures about that. That is the appraisal cost. So data collection and metrics evaluation. Then to test and debug, again there will be a cost which are related to it. These comes under the appraisal cost. Okay, let me just complete, then I'll come to these figures. I'll discuss about each of them. Because the cost, how does it increase? Where to do this? At which point we have to stop? Failure cost. See, if something fails before the delivery of the software, after the delivery of the software, there can be failure, no doubt. So what are the failure costs incurred? How to deal with it? How to categorize them? Shipping, before shipping, after shipping, between shipping. So this failure cost can be divided into internal failure cost and external failure cost. What are the internal failure cost? These are incurred when you detect an error in a product prior to shipment. Before delivery, the error or problems or bugs you just found. So internal failure cost, what does it include? First of all, now you have errors with you. So the cost required to rework or correct an error. The cost that occurs when the rework is done, but it generates more error. How to mitigate with that? The cost associated with the collection of quality metrics, because you need to assess the modes of failure. The cost will be there. So this comes under internal failure cost. But these are the numbers you can easily find out. But what about the other factors? There are other factors also of internal failure cost, about the effort and the software team. How do they feel? The external failure cost, they are associated with the defects found after the product has been shipped to the customer. You already given it. Now the user is facing problem. He will come to you for complaint resolution. It may be replaced also. Return will be there. They will be wanting support, and there will be labor cost, workability cost, who's going to work on it in the warranty work or maintenance time. So a poor reputation and the loss of business will come under the external failure. This is not thought many a times. But a company, the poor reputation, and then the business will be lost. No one will come to you. They'll say, oh, no. They provided a product that was not good. This comes under the external failure cost. So a failure cost will be internal and external. So let me tell you about these figures now. Relative cost to find and repair an error or defect increased dramatically exponentially as we go from prevention to detection to internal failure to the external failure cost. If internal failures are there and you are able to prevent them, it's good. At appraisal time, it's better. But if you need to correct it after the delivery, it's worse. Now see these graphs. Okay. On the left, that is y-axis, we have total cost. X, we have quality improvement. At the time of appraisal, it's good. Prevention, yeah, okay. Internal failure, oh my God. And external failure, oh my God. External failure is costing too much. So I hope you got the idea as a software people. You need to appraise it, find out, verification, validation has to be done on trying to prevent the errors before they can come. And even if it comes, you need to do the internal failure and mitigation and then the final. So at the requirement time, design time, coding time, testing time, maintenance time, you see the requirement time cost, you see the maintenance time cost, and just divide them and find out how much times you need to work. So this is a very good graph. You can have zero error, you can have some error. Getting zero error will cost you too much, but having few errors may work. So there has to be some optimal quality level. On the left, you see y-axis cost. On the right, you have the percentage of defects. So there is a sweet spot. This is the total cost of quality. There has to be optimal quality level. You cannot have the thousands of error and you cannot have a zero error. You need to be somewhere in between. This is the optimal quality level. You see, the cost is also okay and the defects are also okay. You cannot get a perfect quality, but you don't want even to have a non-quality. So there has to be some way you have to be in between. But those failure which are hurting people, killing people, please try to go for a perfect quality. Okay, we'll discuss about this risk in the next discussion. Till then, thank you so much. Take care of yourself.